Hello everyone, welcome back to another lecture of Chemical Engineering Concept 2. Have you ever thought about that? How do we calculate the calories of the food? Look at these foods, like delicious foods. So one of the devices that helps us to calculate the calories, we call it bomb calorimeter. What happens is that we are going to get a food, like a small amount of the food, put it in the bomb section of it, and then by working on some equations, we are going to find out the value of the calories of that specific food. So for today's lecture, we're going to talk about energy balance on closed systems. We will go back to the calorimeter, and you can see it in our course topics. The reference book that we have. Whenever during the lecture you have seen F and R, it's representing our reference book. There is our lecture outline, introduction, the energy balance on closed system, a specific condition that we would have, a couple of examples, play and receive a star section, like always, the real life application and the concept map, and the at the end feedback link. Our learning objective is to hopefully by the end of this lecture, we can apply the term closed process system on an example together, and then explain the first law of thermodynamics and solve the energy balance for closed process systems. Also, we are hoping to be able to identify and discuss the conditions under which each of the 5 terms in the energy balance can be neglected. Here is the quick review from our previous lecture. We talked about the different forms of the energy that we have, how energy moves. So we had a potato example. We said that consider a bowl of potato, which is like, let's say, boiled one, so it's hot. And if you want to move the energy that is inside the potato, one way is that to move the whole ball is like you're moving the mass. Another way, when you touch it, right, you will feel the energy that can come outside the potato. And then we talked about what is the definition of the closed system. Any sealed container can be we can consider it as a closed system, batch process, closed vessel. Any situation that like there is no movement of mass from the boundaries of our system to the surrounding, we would consider it as a closed system. Then we talked about how energy moves on these closed systems. We said that the two methods, heat and work. And then we talked about the law of conservation of energy, the first law of the thermodynamics. So now, why energy balance? Like material balance, energy balance are important aspect to chemical engineering. The balances helps us to determine the amount of the energy that flows into or out of each process unit. To calculate the energy requirement and like the costs that we would have, like the money that we have to spend. And also energy balance help us to assess ways of reducing energy requirement to improve the process profitability. Let's look at the energy balance equation. The accumulation is equal to whatever comes in minus out plus generation minus consumption. What happens when we have the energy balance? Like we are talking about the energy balance. We can't generate or reduce, like destroy the energy. Because of that, the generation and consumption terms, they're going to be zero. We would say delta means that the change from the final minus the initial. Delta U as internal plus the delta of the energy, kinetic energy, and the delta of the potential energy is going to be equal to the Q plus W. Under some conditions, we can neglect these terms. So let's look at here. I wrote it down here. That's the energy balance equation. Delta U plus delta EK, delta EP potential is equal to the Q plus W. So, for example, I'm talking about the delta U, if there is no heat of reaction, if there is no temperature change in our system, in that case, we would say the internal energy, change of internal energy, we would consider it zero. But the kinetic energy, if we don't have any acceleration in our system, then the kinetic energy is going to be equal to 0. If you look at the equation that we had last session on the kinetic energy, you will see that. With the potential energy, if we don't have any rising or falling, so it would be 0. Q and W, the Q is heat. If there is no heat, and W is work, so if there is no W work, like if you don't have any piston to move or something like that, any movement, then it would be 0. Let's have an example. We have a system of heating water in a sealed container. Is it a closed system? Why? Write down the energy balance for this system. Which terms can be neglected? Look at here, I have this, and then it's like that is a heating water. So let's say this one, if I add my temperature, so it's just something that I use it for teaching heat transfer. But I thought that is good heat and mass transfer. It's good that we use it here as well. So if I use my body temperature, so the liquid inside this is going to go up. So it would be like, let's say we have the slowly, but we have the container which is like this, is the sealed container. And what happens is that because it's sealed, right? So we would say that yes, it is a closed system. The next thing, the question was that, okay, is the closed system? Yes. I can draw it like this. Look at here. And then we had water up to here. Would say is the closed one. Write down the energy balance for it. So we wrote it down, the energy balance equation for it. It's like this. Then it says that think about that which terms you can neglect. Because we had like the heating water, so temperature changes. We would have the internal change of internal energy. What about the kinetic energy? Do we have an acceleration? No. So this one would be 0. What about potential energy? Do we have any rising or falling? No. It's at the stationary. So it would be 0. What about Q and W? Are we doing any work into system? No. So that would be 0 as well. So the only thing that is going to remain is going to be delta U and Q. So we will say internal energy here, it's going to be equal to Q. Like if we had the value for the Q, we could say that we could find out the amount of the internal energy as well. Next, play and receive a bonus star. So what I want you to do is that I want you to pause the video here, go to that link. You can go to that link or on the bottom of the screen, or also you can scan it and then you would go and there are some questions. Basically, I'm going to ask you about the whatever we have learned so far. But now let's go to the real life application. Bomb calorimeter is a device used for measuring the heat of chemical reactions or physical change or heat capacity. We will discuss this later in later sessions. What I want you to do is that I want you to watch this video on your own, then try to apply and connect the learning objectives of the which is on slide number 5 to the video on your by yourself. Then have a discussion in your group and share what you think, what you have found, and send me your team analysis after having discussion together of the 3 given learning objectives. So we talked about the energy balance on a closed system. So the next thing, it's very interesting, is like that. Think about this container that I was talking. I said that we have hot water or coffee in it. It's a closed system. What happens when I open the lid? Or it's like that when you want to drink your coffee, or like, I know it's hot. I should be careful because it's really coffee and it's hot. But when you open the lid, and unfortunately you can see the things that's coming like the mass that is going to move around. But in next lecture we are going to learn about that. And the last thing that I want to ask you is that please let me know how did we do today by going to the following link. It's just short survey. I want to see that before going to the next lecture, if you let me know how it was. Thanks for listening to me. Hopefully we know now how energy balance works on the closed system.